Hi everybody, in this video I'm going to talk about how to graph linear functions, specifically from the form called slope-intercept form. Slope-intercept form, first of all, is this form right over here. Now you might notice that there are two others right below it, but we're not going to concern ourselves with what they are called at this time. You can check it out there for yourself anyway. Slope-intercept form is the most commonly used form of linear equations, and the form is y equals mx plus b. Now, a quick note about that. There are two components that are worthy of remembering. That would be your m value, and that would be your b value. Now, we'll go ahead and start with the b value. The b value is what's called the y-intercept. The y-intercept, as you can see from this graph, is any point that lies along the y-axis. And so the value of that point as an ordered pair would always be 0, whatever your y is. So it could be either a positive number or a negative number. But your x is definitely always 0, being that it's on the y-axis. You start there, so you place a point based on the number you have for your b. Then, because you need at least 2 points to create a line, you go to your m value, which is your slope. The slope is also known as rate of change, and the slope is a set of directions. I encourage you to think of it as a set of directions that encourage you to move from your original point, which is your y-intercept. You move from there to another location, somewhere on that line. And that is determined by your changes of your y's or your changes of your x. So if you might remember from another video, slope, when you do changes of y's, has to do with vertical motion, so either up or down, and your changes of x have to do with horizontal motion. In other words, right and left movement. And it happens in that order. So as you read a fraction from top to bottom, you first do up or down movement, then you do right or left movement. So we're going to take a look at some examples here and just identifying the slope and the y-intercept from these three equations, and then afterwards I'm going to show you how to graph straight from an equation without a table. So here we go. If you look at the first one, the first example, y equals 2x plus 4, the slope would be this number right here. And because it's not a fraction, doesn't mean that it's not the slope. You can always think of a single value as a fraction. So I'm going to write this as 2 over 1. And if I had to draw arrows to show the direction, it would be 2 units up, 1 unit to the right. The y-intercept would be this value over here. And so I'm simply going to put that as 4. Or you can write it as an ordered pair. Again, first value 0, then your y number, which is 4. Next one is y equal, or f of x equals negative 3/4 x. The slope here would be negative 3 over 4, not negative 3 over 4x. The x has nothing to do with the slope. And if I put arrows, this negative 3 means you go down 3 units, and the 4 means you go to the right 4 units. The y-intercept is 0, and the reason it's 0 is because, as you can see, nothing follows that negative 3/4 x. There's nothing there to indicate that you have a value. So your b value is 0. In the last example here, the slope is 1/2, and you might be getting the hang of this by now, but the 1 indicates going up and the 2 indicates going to the right. And the y-intercept here is visible. It is your negative 8, and it would be wrong to put simply 8 because this minus sign here creates a negative 8. I want to go back a second to the previous example. The slope over here could also be thought of as 3 over negative 4. I often get asked where that negative should be placed, especially if it's presented right in the middle. The answer to that is you can put it either in the numerator or the denominator. And all that does is change the direction, the way that you move along the line from your y-intercept to your second point. And to demonstrate this 3 would indicate going up, while the negative 4 would mean you would have to go to the left. And if you look very carefully, you can see that the numerators are opposites of each other, and the denominators are also opposites of each other. And so you do cover the same concept, you're just relocating at a different place of the line. So with that in mind, we're going to go ahead and we're going to jump into some examples. I'm going to flip-flop back and forth from the previous screen to this one that you see here, and I'm actually going to I'm going to skip these first two examples that you see and return to those a little bit later. What I really want to focus on at this moment are these two here. Okay, so we're going to start with this, graphing this this equation that you see. First of all, one thing to note is that this over here could also be written as f of x. Okay, they are synonymous with each other. Y and f of x mean the same thing. Both represent the output, but I'm going to leave it as y. So the first thing I want to do is I want to write down the slope, and I'm going to write it in two versions, as you saw on the last screen. So this is 3 over 5. Now this means that I would have to go up 3 and to the right 5. Or if I do the opposite of everything I just said, it would be -3 over -5, and that would mean I could also go down 3 and left 5. Okay, there might be some limitations, but I'll talk to you about what that might be a little bit later. The y-intercept would be 5, or you could write it as an ordered pair, 0 and then 5. It might be a good idea to write it as an ordered pair because it more precisely tells you where to place that point. 0, 5 would be right here. That's my first point. Okay, we begin with that. And then you move according to the directions of your slope. Now, going back to what I said earlier, one of these versions is suitable for our space and the other is not. What I mean by that is this. This is like a frame of a picture, or think of it that way. A picture must always stay within the frame. Then it wouldn't look right if it poked out from the sides, right? So with that in mind, we have to always stay within the frame that we are presented with. And for that reason, I have to choose the version of the slope that will allow me to move while keeping me within this frame. If I were to go up 3 times, according to this one, if I go up 3 times and then to the right 5 times, I would leave this space, as you can see right there, and I don't want to do that. So instead of going up 3 times, I'm going to go down 3 and left 5, which is the other version of the slope. And again, they both mean the same thing. They simply take you to a different part of the line. So from my original point, I'm going to go down 1, 2, 3, and then left 1, 2, 3, 4, 5. And where I stop is where I put my point. So there it is. And now, finally, I'm able to make my line. There we go. Now, you might think, well, you just contradicted yourself. You went against the very thing you said you're supposed to do, which is stay in the frame when you do that line. But here's the thing, these lines are number lines, and this number line is simply slanted. But like all number lines, it is infinite. And because of that, I am permitted to draw these arrows, which indicates infinity in both directions. So it's okay if the line itself leaves the frame, but the points have to stay within the frame because they serve as the anchor for your line and they give it the direction that it needs. Okay, so with that, we can go on to the next example. Number 4. So in this one, I'm going to set up my there we go. So in this one, once again, I'm going to set up my slope. So slope, and that's going to be my coefficient of x right there, and I'm going to write it as a fraction. And doing so means that I would go up and to the right, or alternately, if I do the opposite, down and to the left. So down and left. My y-intercept is 1, which is this number here, or as an ordered pair, I could write 0, 1. Okay, so 0, 1 would be right over here. And then from there, I have to decide which slope would allow me to move nicely within this space, just like last time, without leaving it. Now, fortunately, my slope is made up of small numbers, so my jumps are going to be very small. So either one is okay to use. And I'm going to demonstrate that by using both. So starting with the first one, if I were to go up twice and then over one time, it would look like this. 1, 2, over once, and then I can put my dot. If I were to go with the other version of the slope, I would then go down and left, right? So down twice, left one time, and then I can put my point. One thing to note here is that all 3 points are in line, and that is as it should be, because all 3 points were taken from the slope, which comes from the equation, the same equation. And this is further evidence that it doesn't matter which version you use, as long as you're able to stay within the frame of your coordinate plane. And there you have it. So it really is as simple as that. Now, I do have other examples to give you, and we are going to go up to this one and do numbers 1 and 2 over here, because these definitely look different if you haven't noticed already. The difference between this one, between something like numbers 1 and 2 and something like numbers 3 and 4 is that there's only one variable here and there's only one variable here. So this one is lacking the x and this one is lacking the y. And if you notice these over here, this has both an x and a y, and so does this, an x and a y. And so it doesn't mean that this is going to come out looking not like a line. It will still be a line, but the way you approach it is slightly different. And I'm going to demonstrate this by making a table for this particular equation. So no matter what, this is saying no matter what, x will always be -1. So if that's the case, well then, let me see what that would look like in a table. If x is always -1, I'm not allowed to pick anything else because x is -1. But I can pick any value I want for y, my output. So I'm going to start with 0, and I'll pick +2. Now, I have my ordered pairs already, and so all I need to do is place these on the coordinate plane. So -1, 0 would be here, and -1, 2 would be right here. Now when I connect these, if you haven't noticed already, this is going to be a vertical line. And this vertical line contains points that are all -1 space. They're 1 space over to the left of the origin, the beginning point, which is right there at the center. The entire line is 1 space to the left of the center. And because of that, all the x values, all the other points that are on this line, no matter where they are, they will all have one thing in common with each other. All of them. No matter what they are, we'll start with -1. Because the entire line is at -1. -1 space, or 1 space to the left, making it -1. Okay, and for that reason, when you get good enough at this, you can simply look at this equation and see, oh, this is going to be a vertical line, and it's going to be shifted 1 unit to the left of the y-axis. Okay, another way of looking at this. All right. Oh, one other thing I should add to this is because this line is a vertical line, the slope is undefined. Okay, and what that simply means is that it is not possible to define what the slope is as a number, because there is no such value for vertical lines. All right, let's continue on. Let's go to number 2. So with number 2, it'll be the same type of approach as with number 1. Here it's saying that no matter what, your y's are always going to be a 4. No matter what, y will always be 4. So okay, if that's the case, let's see what that looks like in a table. So if y is always going to be 4, no matter what, then I'm not allowed to pick anything else for y. Okay, the output will always be 4. But I'm allowed to pick anything I want for x. So I can make this 0, and I can make this 1 as an example. And now I have my ordered pairs, and let's see what they look like as points. 0, 4 is here, and 1, 4 is right there. And you should already begin to see that this is going to be a horizontal line. So the very opposite of our previous one. This is a horizontal line. Just trying to make sure it's level. There we go. A horizontal line. Okay. So no matter what, any point that sits on this line, no matter what it is, will have one thing in common, and that is that the y value is going to be at 4, and that's because the entire line is 4 units up above the x-axis. Okay, it's a flat line, and it's simply raised 4 units above that x-axis. So the y is always 4. X's will be different depending on where your points are, but your y's will always be 4. Okay, so 2 different ways of looking at it. When you get really good, you can look at simply look at this equation and say to yourself, aha, this is going to be a flat horizontal line, and it's going to be 4 units above the x-axis, or if it's negative, it's going to be that many units below the x-axis. And that's how this works. Okay. Back to the screen over here, because there is something I need to show you before I show you my last example on the other page. And that is that sometimes equations will not be given to you in slope-intercept form. Remember, there are 2 other forms that these equations could be in. And it is possible to transform one form into another. And the form that I'm talking about right now is this one over here. This is called standard form. Don't worry too much about that unless you already know something about it. But this is clearly not slope-intercept form, which is y equals mx plus b. It's not in that form. And the way I know that is because my y is not isolated, and it's supposed to be in order to be slope-intercept form, as you can see over there. And so my job is to change this whole equation so that my y value here ends up being isolated on one side. Okay, now in order to do this, I simply have to, and SIF is slope-intercept form, by the way, in case you're wondering. So all I have to do to change this to slope-intercept form is begin by focusing my attention on this y and making this my end goal. Get that y alone. And so to that end, I'm going to move this 2x by doing the inverse operation. So I grab the whole unit, the whole term, and I move it to the other side. So these cancel, and what I get is 3y is equal to. Now there are 2 ways to write it. You could write it 6 minus 2x, or you could write this as 3y is equal to negative 2x plus 6. 2 versions, they mean the same thing. Just make sure if you rearrange those terms that the signs stick to the right numbers. And then finally, all we have to do is separate the 3 there from the y. And because they're being multiplied together, all I have to do is divide them. So I'm going to divide by 3 here. And I have to do the same thing to each of the terms on the other side in order to maintain the equality. Okay? And I can do that on the right side as well. Divide by 3, divide by 3, divide by 3. So 3 divided by 3, as you know, is 1. So I get y equals, on the right side, it would be 2, and then minus 2 over 3 x. On the far right side, it would be y is equal to negative 2 over 3 x and then plus 2. Now, something to note here. First of all, we are done. This is now in slope-intercept form. Both of them are. So I'm going to go ahead and box this up and box this up. But there's something more. From this, I have to write the slope. It's a good habit. The slope here is negative 2 over 3. And it's the same over here. The slope is negative 2 over 3. They should not be different unless you simply move the negative to the denominator. And the y-intercept is positive 2, or you can write it as 0, 2, and that's the same for the other one as well. Okay, I'll go ahead and give you the other version of this. You can also write the slope as 2 over negative 3. Okay, there you go. So this is true for both of them, okay? So for both, that is the outcome. So if you ever have to graph a line and it's not in slope-intercept form, and you want to or you need to graph it from that form, you simply have to transform it. Then you can identify the parts that you need, right? And then you can go ahead and do what you need to do. So with that in mind, let's go ahead and do our final example. Here it is. So as you can see over here, there we are. Okay, so as you can see over here, we have an equation that is not in slope-intercept form. And again, I know this because my y value, my y is not isolated. So my goal is to get it to become isolated. And so I'm going to pull this entire equation out here. Plus 5y equals negative 10. And I'm going to begin to isolate my y. So I'll do that by subtracting 2x from both sides. So here it is, negative 2x, negative 2x. Quick note, the reason I didn't put it under the negative 10 like this is because the two things are not like terms. So this and this are not like terms, and by putting them one under the other, you might confuse yourself into thinking that they are, and you might combine them when you should not. So I'm putting it off to the side like that. All right, so then what we get is 5y is equal to, and again, you can write this as negative 10 first or negative 2x first. My preference is to put the x term first because it matches y equals mx plus b nicely that way. Divide by 5 everywhere, and then we have slope-intercept form. Here it is. Y is equal to negative 2 over 5, x minus 2. Now, this is the form that I need to graph my line here. And so, like before, I need to identify the most important things, which are the slope and the y-intercept. I'm going to switch my color here. So the slope is negative 2 over 5, and that would mean going down and right, or it could be 2 over negative 5, and that would mean going up and left. And I'm not sure which one I need to use until I actually plot my y-intercept. But I like having both there so I can decide later. My y-intercept is either negative 2, or as an ordered pair, you can write 0, negative 2. Okay, and that's where we begin with our y-intercept. So here it is. 0, negative 2 is down there. And now from there, I can decide which slope, this one or the other one, I'm going to use. Because my first jump from my point is going to be 2 steps, either up or down, either one would work. They would both allow me to fit. And for that reason, I'm going to go ahead and simply do both versions. Starting with down 2 and right 5. So down 2, 1, 2, and right 5. 1, 2, 3, 4, 5. That puts me right here. And if I go the other way, which is up 2 times and left 5 times. Then what I get is 1, 2, 1, 2, 3, 4, 5, and then I can put my other point there. And you can see that these 3 points are indeed lined up, and again, they are supposed to be if I did everything correctly. So I go ahead and make my line, and again, it doesn't matter if you go all the way through, as long as your points are inside the space, and you're done. That's it. We've done everything we needed to create this line from the equation. So I hope this video helped you better understand the process and thinking behind how to graph a line from slope-intercept form. Please stop by and leave a comment. I'd love to hear what you have to say about how I can better improve my videos. If you have some ideas, please make them constructive. And as always, thank you very much for watching. Take good care. Bye-bye.